Question: a bus is moving at 22 meters per second east for 12 seconds. Then the bus driver slows down at 1.2 meters per second square west until the bus stops. Determine the total displacement of the bus. This is the total displacement of the bus, and we can divide the displacement into two sections. So this is the total displacement, and we divided it into two sections: displacement 1 and displacement 2. For the displacement 1, the bus moving at the velocity 22 meters per second east, and it moved for 12 seconds. For the displacement 2, the bus slows down at the acceleration is 1.2 meters per second square west, and we set the time interval for displacement 2 as delta t2. Then first we find displacement 1. So displacement 1 just equals the initial velocity multiply the time interval delta t1, 12 seconds. So this equals 22 meters per second east multiply the time interval 1, 12 seconds, and this equals 264 meters east. And according to the formula, the time interval for displacement 2 equals the final velocity minus the initial velocity divided by the acceleration. So this equals, here, the acceleration also equals negative 1.2 meters per second square east. So here, this equals the final velocity is 0, so 0 meters per second, minus the initial velocity is 22 meters per second east, and the acceleration is negative 1.2 meters per second square east. Now this equals 18.3 seconds. Then use the formula displacement 2 equals 1/2 multiply the final velocity plus initial velocity multiply the time interval delta t2, and this equals 1/2 0 meters per second, the final velocity plus the initial velocity 22 meters per second east multiply the time interval 2, 18.3 seconds, and this equals 201.3 meters east. Now the total displacement just equals displacement 1 plus displacement 2, and it equals 264 meters east plus 201.3 meters east, and this equals 465.3 meters east.